So for this question here, you were given the coordinates of 3 points. We've got triangle PQR, and you've been given the coordinates in 3 dimensions. You're being asked to find Q to P. There should really be an arrow above that, and Q to R. So we will write down that Q to P will be equal to position vector P minus the position vector of Q. That's your standard result, and remember these would match the components, so your P would be minus, they match the coordinates rather, your minus 1, 0, 3, and that is minus, your components would be 2, 3, minus 1, and that would give us minus 3, 4. So that's Q to P, and you would get 1 mark if you had that correct. You also have to work out what Q to R is. So Q to R would be equal to R minus Q, position vector of R, would be the same as the coordinates, so 1, 5 minus 4, and that is subtracting 2, 3 minus 1, and that would give us minus 1, 2, minus 3, and that would be your second mark in the first part A. Now then you're moving on to part B, calculate the size of angle PQR. Now for this, if you are being asked to work out the size of angle PQR, and they have just asked you to work out the 2 vectors that we've just been worked out there, so we had to work out the vector Q to P and the vector Q to R, and they're both going away from the point Q. So this angle here would be our angle theta, the angle between the 2 vectors, and that's basically what you're being asked to work out, angle PQR. Now the formula that you would be using in order to do that would be an adaptation of the scalar product. Now what you will see on the formula list is this: A dot B equals magnitude A, magnitude B, cos theta, and of course that then needs to be rearranged, but also rearranged and adapted to suit whatever vectors you're working with. Actually, rather than writing theta here, unless you've got a diagram, now it is okay if you've marked theta in the diagram like I have. If you haven't, you need to be writing down the angle, so cos PQR will be equal to, and it will be the dot product of these 2 vectors that we've worked out, so Q to P dotted with Q to R, and that is all over the magnitude of each of these vectors. So that's what we're going to be subbing into, so you need to have that formula stated. So I'm separately going to work out to the side here, I'm going to work out Q to P dotted with the Q to R. So for us that means vector minus 3, 4 dotted with the minus 1, 2, minus 3. So that's going to be minus 3 times minus 1 plus minus 3 times 2 plus 4 times minus 3, and that is equal to positive 3 minus 6 minus 12, which of course is minus 15. Now, having done that, that earns you in this second part, that would be where your first mark would be for getting that dot product. Your second mark is for collectively working out both of these, the magnitude for each of these. So Q to P, the magnitude is equal to square root, and remember, if you're doing this on the calculator, brackets round the negatives when you're squaring them. And squaring all of that, each of those, make sure the root sign covers all of it, and that would be the square root of 34. You also need to do the magnitude of Q to R, and that is again squaring each of the components. So you've got 2 squared, you've got minus 3 squared, doing all of that in the calculator, and you'll get root 14. Now you need to get both of these correct. If you make any numerical errors, right, you will lose that mark, even if one of them's right and the other one's wrong. So it's important. Now what's important is that you've stated the formula that you are using and that you're now going to substitute into this formula. So you're going to have cos PQR would be equal to, we have that negative 15 on the top of your fraction all over the square root of 34 times by the square root of 14, and that's going to give you a value. But to work out your angle, remember, you will need to take the inverse of this. So cos to the minus 1 of negative 15 over root 34 times root 14, and that will give you an angle. Now you would expect to find that it will be bigger than 90 because we're dealing with a negative here, and we do in fact end up with 133.4344, all of the other digits. So 2 decimal places, PQR would give us an angle of 133.43. Make sure you put your degrees in when you do that. So your second mark is the magnitude. The third mark that you earn is for both of this stating the formula clearly and the substitution into that formula, and then the last bit is where you would earn your fourth mark. So check your work in. Look for any places that you might improve, even your layout, make sure it's quite clear and precise what you've done.